Hello everyone, in this video we're fixing a critical inventory race condition inside a backend checkout API on Develow.com. Right now our store allows shoppers to add more units of an item to their cart than actually exist in the warehouse catalog. This leads to broken expectations and canceled orders downstream. We need to jump into the Develow IDE, use the Develow AI chat to parse our catalog models, and implement a strict boundary check that rejects overdrafted items with an HTTP 409 status code before the cart state is ever mutated. To approach this fix professionally, we'll start by using the Develow AI chat to get a map of our local properties. Demonstrating structural discovery using precise prompts is exactly what interviewers look for when evaluating your workspace habits on Develow. First, we prompt the AI. First, let's find the data models. How is product catalog pricing and warehouse stock initialized on the server? DVL points us to our internal catalog layout containing the available stock limits. Next, we verify our execution path by asking, where are the API routes or controller operations for appending line items to the cart? DVL directs us straight to the addition routine in API/src/store.js. Finally, we establish our exact guardrails by asking, what do the tests look like in test/stock.test.js? The AI highlights that the tests verify cumulative additions. If a user adds 3 items and then adds 3 more on an item with a stock limit of 5, the second request must fail with a 409 error without modifying the cart. Let's look at the implementation logic. The core problem here is a failure to check cumulative state. A common mistake is to only check the newly requested quantity against the stock limit. But if a product has 5 units in stock and a user adds 3 items twice, they'll end up with 6 units in their cart, overdrafting your inventory. Our goal is to implement a defensive logic check. We must figure out how many units of that item are already sitting in the user's cart, add the newly requested quantity, and ensure the combined total never breaks past the absolute catalog stock threshold. Let's open API/src/store.js to build our stock validation gate. Locate the routine where items are appended. Right after verifying the product exists in the catalog and checking for an existing line item in the cart, we insert our 4-line surgical validation block. First, we establish our baseline by writing const current equals existing $existing.quantity:0. This determines how many units are currently in the cart. If the item isn't in the cart yet, it defaults to 0. Next, we write our validation threshold gate. This condition is exactly what the grading suite looks for. By adding current and QTI together, we calculate the prospective final state before actually modifying the data array. If that value exceeds product.stock, we halt the thread instantly and pass back an explicit 409 status block. This completely protects our data boundaries from overdrafting, while letting valid purchases flow down to the mutation logic below. With our validation code saved, let's bring up the integrated terminal window right here in the Develow IDE to verify our solution. We run Docker tests. The test runners execute, pushing bounds on bulk additions and cumulative increments, and our API catches every edge case, returning completely green across the board. Enforcing state validations against database constraints prior to mutating storage arrays is a cornerstone of defensive backend design. By using the Develow AI chat to quickly break down our structural models, we kept our inventory operations perfectly secure. This ticket is now resolved. Bye for now and see you in the next code challenge.